Okay, we'll start screaming. Let's see. Aha! Starting. Very nice. Alright, wait. Okay, this is 20 in 5 seconds. Alright. Hi, everybody. My name's Ian McLaughlin, and I am a PhD candidate for now at the University of Pennsylvania, and I study anxiety and addiction, the neurophysiology of both, perhaps unsurprisingly, given that it's a neuroscience department. And so, to begin today, there were two articles that caught my eye that hit the popular press, and they were both based off of primary research. One of which, I don't know that the scientists themselves would have made so strong a claim as were made in the popular press, and the other is more just interesting basic genetics that was done. So the first has to do with a claim on free will. And so if anybody's ever done any reading on the debate as to whether or not free will exists, they've probably come across the name Benjamin Libet, or just Libet, L-I-B-E-T. And so this was a scientist who put out a study using basically EEG in the 1980s. And oftentimes that study is used as a sort of framework from which all other claims on which all other claims regarding free will are based. And I think for a long time now, there has been an interest in evaluating just whether or not the claims that are made based off of Benjamin Libet's work are legitimate as a function of whether or not the findings or the interpretations of that study were accurate. But we can go back a little bit further before Benjamin Libet's work to 1964, where some German scientists, also using EEG, studied 12 people. And so basically it's kind of a similar experimental design, which is probably why Benjamin Libet designed his study the way he did. But basically the idea is that there was just one task, a very simple situation, where they have an EEG strapped to their head. So an EEG is basically just a lattice of electrodes that can measure changes in electrical potential along the most superficial or outermost layers of neurons. And the task is to flex a finger on their right hand at whatever random interval they want it to, up to 500 times. So they're just sitting there, right? And what these researchers were interested in establishing was whether or not they could detect, they used a German term for it, of course, but it basically means a readiness potential. So, in other words, the brain readying itself to execute an action. And so then, 20 years later about, Benjamin Libet used that model in a sort of very similar way. And so his findings had been interpreted by, or to mean that choice, whether or not there was a decision as to whether the decision to move a finger could be detected prior to the person themselves knowing that they made that decision. So in other words, if a scientist could predict what a person was going to do before that person was aware they were going to do it. And so there is a quote from this popular press article that goes, quote, "It would be quite an achievement for a brain signal 100 times smaller than major brain waves to solve the problem of free will, but the story of the readiness potential has one more twist. It might be something else entirely." And then the author goes on to say, "It was never meant to get entangled in free will debates." So just at the outset of how this new study, which we'll be talking about in just a second, is being discussed in this article, this just isn't how science operates. It's not up to the scientist who makes the discovery as to how those findings are going to be used. It's up to the community of scientists. How a finding is ultimately applied is not up to the original scientist. Findings are synthesized and reapplied and reanalyzed to produce new findings. So it doesn't matter what Benjamin Libet felt about his studies or how he himself interpreted the findings. And so, all right. So, this debate as to whether or not free will exists or whether or not we are sort of at the whim of subconscious processing and we just feel as though we have free will has been debated for a long time in neuroscience. I mean, it's still debated in neuroscience. And all throughout there has been this critique that results were accurate. Benjamin Lebet's results were accurate. But the conclusions that many in the field were coming to, that free will likely doesn't exist, at least in the way that we conceive of it, were likely based on an unsound premise. And that premise was, the assumption was, that this readiness potential that scientists were measuring, right, a signal in the brain that preceded the conscious awareness that somebody was deciding to move their finger, the assumption was that that readiness potential perhaps did or did not cause the action in the first place. The assumption among those arguing that free will didn't exist was that it did cause the ultimate action, and that readiness potential, again, preceded the conscious awareness that the person was then going to tap their finger. Okay, so on to the recent study. It was conducted by a guy named Aaron Schurger. I'm not quite sure that that's how you pronounce his last name. And he is at the National Institute of Health and Medical Research in Paris, in France. And so, just another quote from this article. Schurger studied fluctuations in neuronal activity, like the churning hum of the brain that emerges from the spontaneous flickering of hundreds of thousands of interconnected neurons. This ongoing electrophysiological noise rises and falls in slow tides like the surface of an ocean, or for that matter, anything that results from many moving parts. And then Schurger then has a quote in the article saying, just about every natural phenomenon that I can think of behaves this way. For example, stock markets, financial time series, or the weather. And the author of this Popular Press article is a very good writer. I think she's a beautiful writer. But dynamics at different domains of nature, they often do reflect each other, but at least as frequently they don't. And so, it's not necessarily optimal to approach a complex series of interactions with the expectation that what is going on at a level at which we're used to is applicable to this other domain of nature. And so another thing is that all of these studies are operating at a sort of broad level of analysis that doesn't really engage the brain on the level at which we at least theorize it operates, right? Neurons with specialized functions communicating with other neurons with specialized functions. And so, we're having a kind of a different conversation when we're coming to judgments about how the brain operates based off of these very, very broad waves of activity. He thought, right, that if Schurger explains his approach to evaluating these experiments by highlighting an insight that he had, which was to sort of line up this noisy data, these noisy fluctuations in neuronal activity, according to what he described as peaks, and then reverse average, and then there's some technical terminology with regards to like how they process data, but he comes to a point where if he applies the same method to the spontaneous brain noise that he studied, would he be able to detect this readiness potential? And so an important distinction, however, between the way that Benjamin Lebet, again, that researcher from the 1980s, conducted his experiment, and the way that Aaron Schurger conducted his, was that Lebet didn't have a sort of a baseline control. Excuse me. And so there was no sort of source of external cues for when one might tap their finger. And so he included, right. So he makes the argument that these spontaneous actions that these people executed, that these study participants executed, might just coincide with what he calls the haphazard ebb and flow of the participant's brain activity. So they'd be more likely to tap their fingers when their motor system happened to be closer to a threshold for initiating movement. And so, I mean, for me, like, this doesn't disprove the claim that free will doesn't exist. And, for a variety of reasons, sensitivity to what is too long to wait, like how long is somebody going to wait between the decision to move the sensation, the decision to move their finger, or expectations of when the scientist might sort of want them to tap, and these can be completely subconscious, are what produces these signals from motivation circuitry in the brain that ultimately result in the elevated likelihood of the motor system neurons firing such that they tap their finger. And this is precisely what we're talking about when we describe free will as, or when we describe human behavior and human consciousness as an iceberg. The iceberg metaphor being that the component of human consciousness about which we are actually consciously aware is just the tip of an iceberg, which is, the foundation of which is this majority of the iceberg that's underwater, and all of that is subconscious, and we have no agency over those subconscious processes. And so I guess maybe I should just cut to the point here. And so before I cut to the point, another advantage that Aaron Scherger had that Benjamin Loubet or those original German scientists in 1964 didn't have, of course, was using an artificial intelligence-based data analysis approach. You might have heard of machine learning, for example. And so while I think that this study did indeed, this might be a little loud, sorry. This study did indeed complicate our interpretation of Benjamin Loubet's original work. It doesn't necessarily confront the fundamental issue regarding the relationship between subconscious processes, by the way, those are the ones that I study, and conscious awareness. And so it doesn't actually matter whether or not Benjamin Loubet's original study did indeed detect a readiness potential or a signal that preceded an action that a scientist could detect that could predict whether or not a person and when a person was going to execute some kind of action. So I have more there, and maybe I can talk about that when we go live. But I guarantee you will, in the next year, you'll see a study that contradicts these claims. And the frustrating part of it for somebody like me who studies specific circuits of neurons in simpler organisms, the frustrating part of it to me is that all of these studies tend to use what you might call cognitive neuroscience imaging techniques, or something as simple as an EEG, which is quite rudimentary at this point, given what we can do with neuroimaging technology. And what's frustrating is that all of these methods measure very broad levels of brain activity. They're incapable of resolving neuronal activity down to specific neurons or circuits of neurons. It is just general regions of activation. And that is just not, at least for me, the language of the brain or the language of consciousness. It's very insightful. It can give us ideas as to where to look for the more gratifying answers, which are, okay, which circuits of neurons are controlling these behaviors and how are they related to each other? And then perhaps at that point we can begin asking the question whether or not we can indeed predict somebody's action before they're aware of it. But for me, at least, in my humble opinion, whether or not another cognitive neuroscientist is going to be able to disprove or prove or buttress the claims from Loubet's experiment are sort of inconsequential. At least inconsequential to the argument as to whether or not free will exists. Okay. That went on a little bit longer than I expected. Sorry. I was up kind of late last night. Anyways. Reading about fasting, by the way, which will be the next topic of my podcast, which is called Wired to be Weird on iTunes and Stitcher and Google Play and stuff. All right. So there was a study as sort of like personal and intimate as it is. Why it is that some people are left-handed versus right-handed has been a question that's sort of plagued neuroscientists or scientists for a very, very long time. And we still don't have an excellent idea as to what it is that distinguishes a lefty from a righty, or why it is that somebody might be left-hand dominant versus right-hand dominant. And there had been some studies that had come out in the past few years that suggested it is a very basic level of biology, very so basic as genetic inheritance or epigenetic regulation. And so this study basically took the approach of studying a massive number of people in the UK. And so one of the authors of the study, Akira Weiberg, who's a medical research council fellow at Oxford University, he or she maybe, explains their findings as this quote. This raises the intriguing possibility for future research that left-handers might have an advantage when it comes to performing verbal tasks, but it must be remembered that these differences were only seen as averages over very large numbers of people, and not all left-handers will be similar. And so he or she is highlighting that not only did this group find that left-handedness correlated with specific genes, and we'll get into which those genes are, just a handful, but that left-handedness correlated with a bunch of other cognitive capabilities as well as mental illnesses. And so Gwenaël Daoud, I'm just butchering these last names, and I'm sorry about that, was I don't know if she was the lead grad student on the research, but certainly a co-author. Describes the study as follows. So they studied the DNA of 400,000 people, which included just over 38,000 lefties from the UK Biobank. And they were successful in isolating 4 genetic regions that were associated with left-handedness. And so you're going through all of these various, we all have slightly different genomes. Even, siblings have slightly different genomes. Siblings have, of course, their genomes are more similar than people who are not, directly related that way. And so it turned out, and so you're going through all of these slight nuances among people, the genomes of a large number of people, and you're finding which of these unique quirks tend to predict whether or not somebody is going to be a left-handed or right-handed person. And so they honed in on these 4 specific genetic regions in the genome, and 3 of the 4 were linked to these very basic levels of neuronal architecture, let's say brain architecture. And they are proteins that influence things like brain structure and development, and specifically, for example, microtubule related function. Microtubules are, you can think of them sort of as like the scaffolding of neurons. And so then they moved on to correlating some of these other, they were fortunate to also have some neuroimaging data from a lot of these lefties, a lot of these people. And so they evaluated neuroimaging from 10,000 of the people that were studied, and they found that the genetic variants that were associated with left-handedness were also associated with differences in white matter tracts. So white matter, as opposed to gray matter are the sort of neuronal cell bodies, the neurons themselves. White matter indicates where the connections between neuronal cell bodies are. And so with regards to left-handed people, the left and right sides of the brain communicated in a more coordinated way, is the way she describes it. This is again Gwenaël Daoud. And so she said that left-handed people have a higher synchronization of natural oscillations of your brain, and these oscillations still happen when you are idle. So when you're just not necessarily focused on any given task, you're just sort of chilling. And so that's an interesting, consistent distinction between lefties and righties in terms of, again, these very broad levels of neuronal activity or brain activity. But they also detected this predisposition to disease that lefties exhibited. And so Dominic Furness, who is also an author on the paper, and he's also at Oxford, says it has long been known that there are slightly more left-handers among patients with schizophrenia than the general population, and by contrast, there are slightly less left-handers, fewer left-handers with Parkinson's disease than the general population. So it might be the case that whatever it is that is causing some folks to become left-handed, which is about 10% of the population, may also be associated with a predisposition to schizophrenia and other mental illnesses, by the way, but then also might protect against something like Parkinson's disease. It may or may not. These correlations are not, one-to-one. They're not super, super strong. But these are large numbers of people. And so, this is statistically significant. So he further comments and says, suggests that these diseases, along with handedness, are the product of fundamental differences in brain development, some of which are driven by genes, right? So just like we just said, some of these, whatever it is that causes some folks to be left-handed might protect against something like Parkinson's disease, but then predispose to something like schizophrenia. All right, and so, in case anybody's interested, the significant loci in genomes that they identified were, again, microtubule associated, so MAP2 and MAPT, and then WNT3 and MICB. I'm not actually familiar with MICB, but all of these are very, very basic sort of architectural, like developmental structural related genes, or they regulate the development of brain structure. And so they have been, over the years, associated with a bunch of neurodegenerative diseases as well as psychiatric conditions, of course, all of which arise from the brain. All right. So, yes. Oh, yeah, right. Okay. So one of the interesting findings that I didn't want to leave out here that isn't likely going to be covered in popular press, just because it's sort of I don't know, maybe a little bit arcane, was that they found that there was stronger involvement of right language related brain regions in lefties associated with weaker suppression of the default mode network influence on right language functional network. So all of that means that in these lefties there tended to be less influence of something called the default mode network on right language functional signaling. So I know, again, that probably all sounds still quite arcane, but the default mode network is a circuit, a very disparate, very broad circuit within the brain that tends to become more active when you're not focused on, you're not devoting your attention to any given task. You're just sort of introspective. You're zoning out, maybe. That's probably the time where you feel the DMN active the most. Of course, you can't actually feel it active, but you can become aware of it becoming active, I suppose, which is kind of a contradiction in terms. But you can observe it becoming active when you're just sort of zoning out, maybe when you're sitting in class or you're watching a movie and you're just not particularly compelled by it. And so it just turned out that what they found in the neuroimaging data from these all of these people that they studied, that they had genetic information for, lefties tended to have less of an influence of that DMN, that default mode network, on language-associated signaling, suggesting that might be a structural-based distinction, that is present in lefties. It's not present in righties. That might be what enables this increased verbal, these slightly increased verbal capabilities that can be detected in left-handed folks compared to right-handed folks. I thought I took down a quote regarding that verbal distinction. Oh, yeah, another thing was that they didn't just stop at schizophrenia. That wasn't the only mental illness that they highlighted that was correlated with left-handedness. Others included just neuroticism, predispositions to mood swings, and then, some specific anatomical distinctions that it's not probably worth really going into. So, interesting stuff. I happen to write with my left hand, but do basically everything else with my right hand and play sports right-handed. So I'm not quite sure where I would fall in this slew of genetic information and neuroimaging. It's something I've always wondered about, but yeah, interesting stuff. So it just might be the case that, again, whatever causes some folks to develop left-hand dominance might also be associated with this predisposition to verbal performance, as well as mental illnesses. Something I've always found kind of fascinating about schizophrenia is that there is a very consistent verbal component to schizophrenia. Oftentimes, one of the symptoms that people with schizophrenia exhibit it's called different things, but word salad is one of the more sort of informal descriptions, which is just sort of like they are capable of saying things that sort of sound coherent, sort of. They sound like they might make sense, but if you really think about what they're saying, it's completely incoherent. So the words are properly formed, but it's sort of meaningless statements. Another term that I love is clang associations. That's some folks with schizophrenia will exhibit. So my favorite phrase that I remember learning from way back in the day was, you might ask somebody with schizophrenia, or some folks with schizophrenia, how they're doing, and there was a quote that was biting wires and lighting fires, and it's like, I think I understand what that means, but I'm not quite sure what that is. It's a clang association. It's like a meaningless association between words that is somehow emerging from the unique brain of somebody with, or some folks with schizophrenia. All right, so sorry, I wish I had been able to prepare that a little bit better. I've just been so crunched for time, and the only time that I can squeeze out of my day these days is sleep time. So I haven't gotten as much sleep as I generally like to. But with that, oh wait, let's bring this up. With that, let's go live. Thanks for hanging out, everybody. All right, let's see. Boom and boom. All right. Hi, everyone. My name's Ian McLaughlin, and I'm a PhD candidate for now at the University of Pennsylvania. I'm wrapping up my dissertation and last publication. I study, for anybody that doesn't know, I study anxiety through the lens of addiction. I study the neurophysiology of anxiety, but I do it in addiction lab, which has been an advantage for me, I would argue. And so I just talked a little bit about, two things. A study regarding that purports to disprove one of the kind of foundational studies that serves, or that folks that argue that free will doesn't exist, that purports to disprove that study, and then also a recent study that identifies potentially one of the causes, or perhaps the cause, of left-handedness. Both of which are, cool studies, but I had a little bit of a bone to pick with the anti absence of free will study. So if you're interested, check out the YouTube. I have a little YouTube thing. Explain the art. Okay, yeah, sure. So this is art. So there's actually more of them, but we would traverse into more private parts of my apartment. So I have 4 of them. They're different masks. They're made by South American artists, and they've been in my family for almost ever since I developed consciousness, but when I was very, very young. And my parents moved from my childhood home, and they were like, hey, we have these big honkin' paintings. Do you want them? And I was like, are you kidding me? And so I didn't make this art, but I really enjoy them. I have masks throughout a lot of my apartment, actually. Yeah. Okay. Does left-handed have a rapport to sex? I'm not quite sure what you mean by that. Like, is it associated with a unique set of sexual behaviors? I am not aware of any studies that have certainly ever proven something like that. But left-handedness does correlate with, first, an increased predisposition to certain mental illnesses, a lot of them. But then also tends to be associated with a reduced risk of Parkinson's disease. And the study that I was discussing, or that I briefly brought up just now, found that there was some consistent differences in how broad circuits within the brain operate during the production of language. Folks with left-handed folks also tend to exhibit slightly increased performance in sort of verbal tasks. Yeah. I feel like there's something wrong with my mother's brain that went undiagnosed. Well, that's certainly possible. One of the one of the things that became very remarkable to me as I was going through the sort of early education of a PhD was that things don't go wrong way more frequently, just given how sort of precariously devised the brain is. It's extraordinarily fragile. It can only operate optimally within a very small range of temperature. And of course, all of these different characters and, these different proteins and enzymes and transcription factors have to interact in such a way as to maintain this, extremely complicated organ. And of course, things do go wrong, particularly as we get older. And there can be very subtle injuries essentially to the brain that can occur that you don't really know are happening until there's some disruption of function. And, just some examples. One is a transient ischemic attack, or a TIA. You probably heard of strokes. Maybe you're familiar with what a stroke is, which is essentially just a deprivation of blood delivery and oxygen delivery to various parts of the brain. Depending on where in the brain it occurs and how big of an area is affected, you can have more or less severe symptoms. A TIA is sort of like a little mini stroke that by definition will affect a smaller region of the brain, and therefore will be less severe in its outward manifestations, but it is still an ischemic attack, and they can occur with a frequency that then can ultimately accumulate in damage that then becomes problematic. But there's no like big stroke that's easily detectable using neuroimaging techniques. And then the other one, of course, is subconcussive brain injuries. These happen all the time, and you don't know them. You don't know that they've happened necessarily because, of course, you didn't have a concussion, so you didn't lose consciousness or anything. But your brain is jarred up against the skull, nonetheless. And we can tolerate a couple of those injuries. Some, it seems, more than others. There does seem to be some kind of genetic resilience that some folks have, but if it recurs throughout life, you can get an accumulation of damage, and then something like chronic traumatic encephalopathy can arise. Okay. Can someone that is brain dead from a stroke be reversed? Family member. I'm sorry to hear that, Cells. Brain... Physicians will use the term brain dead, usually not with patients, but in different kind of contexts. So let's, for the purposes of this conversation, let's describe it as there's just no higher order brain activity whatsoever. That is among the more severe circumstances that one can be in following any kind of brain injury. It doesn't only arise from a stroke, but it does indicate that there is rather severe damage, and as time goes on, whatever caused that damage, for example, one can develop that due to a car accident, or like you say, a stroke, or an aneurysm, right? And so depending upon, a car accident can deliver an extraordinarily severe injury to the brain, but it was the car accident itself that caused that damage, not a stroke. Right, where a stroke, something went wrong in the vasculature that may or may not continue to pose a threat to brain health. But so generally speaking, were it my family member, I wouldn't expect there to be a full recovery. You never know. Marvelous things can happen given modern medicine, but generally speaking, that's a pretty severe state of affairs, and I'm sorry to hear it. I've certainly had personal experience with that myself, so I empathize. Okay, are computers faster than brain impulses? Well, it really depends on what you mean by faster. They certainly can't move as fast as we can, right? But are they capable? So here's what I think you're probably interested in, and I'm just being kind of cheeky, as I think my friends in the UK might say. Do signals transmitted between neurons, are they faster or slower than signals that are transmitted by computers? Well, let's take the optimal case situation, right? Where, the optimal case for a brain is just the brain operating as it does. Just because somebody might seem smarter doesn't mean that their brain is, that neurons are communicating with one another more rapidly. In fact, there's a very consistent speed at which neurons fire impulses, and impulses are capable of traveling between neurons. Now, computers, however, are capable of handling a multitude of different signal modalities. So, for example, they can operate according to fiber optics, light transmission, and as far as I'm aware, there's nothing in the universe that can travel quite as quickly as light, and so. While our nervous system is sensitive to photons, to light, it still, and by that I mean photoreceptors on our retina, or the mechanisms that enable us to see different wavelengths of light. While they are sensitive to light, what happens after those photons traveling at the speed of light crash into a photoreceptor is that then the wet stuff of our nervous system has to process that event. And that is the same speed that a nervous system always processes information, which is actually kind of slowly, on the order of, let's say, milliseconds. Now, a computer could be designed to operate much more rapidly. And so this isn't the main reason why once we generate something like an artificial intelligence and it is capable of improving itself, that it will rapidly surpass human intelligence. But it is one part of the reasons that, computers are just sort of limited by the laws of physics, and we're limited by not only the laws of physics, but also the features of our biology, the frailties and wonders of our biology. All right. Sorry. Okay. Jeez. Very cool art. Thank you. It's been getting a lot more attention recently. Interesting. Thank you for answering. My pleasure. Okay, he had a stroke on the left side and then one on the right side, according to the doctor. Yeah, so unfortunately, that can happen, as strokes can happen in succession, um, and depending upon where along the vasculature, the arteries really that deliver blood to the brain, depending upon how low along that vasculature, whatever oftentimes strokes arise from plaque becoming dislodged, flowing through a vessel, and then getting stuck in the vessel, preventing blood from flowing. And depending upon how low along that vessel that occurs, that is just one cause of stroke, but it is a common cause of stroke. You can have greater or less damage that arises because neurons are extremely metabolically active. They need a lot of not only nutrients, but also just oxygen delivered by blood. And so if if neurons are deprived of blood delivery for not very long, they begin deteriorating and dying. How much do you earn? So I am still a graduate student, and graduate students are not really known for their income. I'm at the University of Pennsylvania, which is a very large institution, and so I'm fortunate to be compensated better than a lot of grad students. Graduate students in STEM, or in sort of science, technology fields, tend to be more generously compensated than PhD students in other fields, but it's still not a ton. So the number that if you were interested in what graduate students make in neuroscience, you could expect to see a range between $16,000 a year to just over $30,000 a year with health coverage, oftentimes provided by the institution itself. And then you can supplement that with fellowships and stuff like that. But generally speaking, that's the range. So it's not a ton. It's nothing, right? But then after you finish your PhD, you can either go into do a postdoc, stay in academia, in which point you're compensated more because of course you have more expertise and your responsibilities have increased theoretically. Or you can go into industry, which is the private sector, biotech, the pharmaceutical industry, if that's your that's what you're interested in. You can be compensated much better, in six figures and that kind of stuff. You can. The private sector encompasses more than just pharma and biotech, but yeah. So the Porsche doesn't happen until after the PhD. Yeah, that's right. Aside from stigma, does cocaine have any more deleterious effect than caffeine biologically? Yeah, so it's astute for you to put them in the same category of drugs in that they are both psychomotor stimulants, but that is kind of where the similarities kind of stop. They have very different mechanisms of what we call pharmacological mechanisms of action. Caffeine is a pretty mild stimulant when you get right down to it, and that's because the way that it is stimulating is that it gets in the way of a neurotransmitter that would normally bind a neurotransmitter receptor. That neurotransmitter is called adenosine, and it's not the sexiest neurotransmitter out there. It doesn't really mediate anything as so much as glutamate or GABA, some of these other neurotransmitters that you might have heard of. But then even the more modulatory neurotransmitters upon which cocaine exerts its action, the monoamines, specifically the catecholamines, that's dopamine, norepinephrine, and to a lesser extent, serotonin. And so the reason cocaine is so much more addictive than caffeine, at least for some folks are protected against cocaine addiction, is that it has a direct effect on dopamine signaling. And in fact, cocaine for a very long time has been used as the kind of quintessential addictive molecule. Now, there have been problems that arose from doing that because, cocaine, of course, is very different from a highly addictive drug like heroin or oxycodone or nicotine. But they all do share this one thing in common, which is what cocaine does very well, which is elevate dopamine levels in a circuit of the brain called the mesolimbic dopaminergic circuit. Caffeine does that too, but it's a rather indirect effect. So now cocaine is, of course, caffeine isn't really consumed in all that many ways, right? It's usually imbibed. You can also, eat caffeine tablets, but I don't think there's any significant number of people out there that are smoking caffeine. You can smoke cocaine, so long as you have converted it into a free-base form, and what we colloquially refer to as crack cocaine. And so when you smoke any drug, that delivers a much larger amount of the drug to the brain at one time, which is why it tends to be more addictive. And so when one does that, or when one has been doing cocaine for a long time, the neurons that it stimulates, those mesolimbic dopaminergic neurons, do begin to, they can die via excitotoxicity. But then also, even if you don't have neuronal cell death, your brain will adapt to the chronic presence of the drug such that the reasons that one is consuming the cocaine, feeling excitement, getting high, feeling energy, the reason that folks feel that when they take cocaine is that the parts of the brain that a drug like cocaine stimulate are what mediate those experiences. And so in the long term, one can develop mood-associated conditions that would require clinical intervention. Lethargy, attention problems, memory problems, and particularly all of those things are exacerbated when one smokes crack or smokes cocaine. Is it, stigma aside, and I totally, appreciate, put the stigma aside, it's not particularly useful. It is just the case that cocaine is a more kind of precarious drug to take than one like caffeine. All right. What do you think of this new research on gut bacteria to blame for depression, etc.? Yeah, so that kind of research has been coming out for a few years now. And in fact, a lot of labs that were neuroscience labs that were devoted to understanding addiction or mood-associated signaling have at least integrated some component of microbiome research into their work. So for anybody that's not familiar, so I say microbiome. Gut bacteria generally is what people are referring to when they say microbiome. The microbiome is just a term that refers to the entirety, the full profile of all of the different microbes that inhabit not only your gut. You have microbiomes throughout a bunch of different parts of your body. You have a microbiome of your eye, for example, microbes that live on your eye. You have a skin microbiome, hair microbiome, right? I think you get the point. But of course, the gut is this. I like to always use, I'm sure I didn't come up with it, but the metaphor of it being like a coral reef, where the coral reef itself is alive, and that is your intestines and stuff, the stuff of your gut. But then, of course, the interesting part of the coral reef isn't the reef itself necessarily. It's all the things that live in and on the reef. And that is sort of like what microbes are doing when they're inhabiting your gut. And the reason that they're important is that they aren't just passive residents. They can take some of the molecules from your diet that you've, of course, eaten and then has arrives in your gut. They can take some of those molecules, convert them to other things that can influence everything from your metabolism, obesity, cardiovascular disease, but then also there's less, but accumulating evidence that they can also influence central nervous system activity, and there is evidence that they can influence things like susceptibility to depression and anxiety-associated conditions. And what do I think about? I mean, if you're asking if I believe that it's can I get to believing that? Absolutely. I would be shocked if there weren't a very complex set of relationships between the microbes that inhabit a person's gut and their central nervous system activity. And there are so many, ways by which that could occur, one of which being we know that the presence of certain microbes, and no two people have identical, an identical repertoire of microbes that inhabit their gut. And a lot of research has shown now that the presence of certain microbes can be associated with a kind of chronic inflammatory signaling that can be very unpleasant, of course, but chronic inflammatory signaling peripherally in the body outside of the brain has been shown to potentially exacerbate underlying psychiatric conditions like depression. That's just one mechanism by which I can imagine, if you happen to be colonized by a certain microbe that happens to cause this subtle inflammatory response, that you might be then predisposed to, psychiatric illnesses. We can expect. We can all expect the next 10 years to reveal quite a bit about not only what microbes in our gut are doing, but then also how we might be able to manipulate that landscape to achieve desired outcomes, to improve, for example, treatment outcomes for the treatment of type 2 diabetes or ALS, even a wide variety of conditions. Strange questions, but would I like to have a piece of Einstein's brain? Yeah, absolutely, totally. But I actually have seen pieces of Einstein's brain because I think they're still on public display at the coolest museum in the world, the Mutter Museum, or as Mutter would have you pronounce it, the Mutter Museum, here in Philadelphia. It is literally one of the coolest things you can do when you come to Philly. Of course, Philly is known for the the birth of the American Democratic Republic. So there's a lot to see with regards to that. But it also is the home to one of the, I think maybe the first College of Physicians, one of the earliest medical institutions in the world. I think UPenn, by the way, was the home of the first medical university. But so we have this museum here, the Mutter Museum, and there are all kinds of very wild and exotic and really cool specimens. I can't talk it up enough. But for a while now, I think still, they've had specimens of Einstein's brain. Now here's the catch. I handle brain tissue all the time. In fact, it's one of the things that I'm best at in terms of my techniques. And I'm very precise about the way I handle my brain specimens because I want to be able to sustain as much of the biological landscape as I can, prevent it from being damaged, because once it's damaged, it's never recoverable, and you've just lost information, lost potential discoveries. The story of what happened to Einstein's brain is wild. It was lost for a long time. It was not preserved well. Of course, it's not like, they had very modern tissue preservation methodology back then, but it wasn't exactly like the Stone Age. And so as a result, the slices of Einstein's brain that you can see are they're preserved like the way maybe like an intro biology class might preserve a specimen. And so it's just not particularly informative, unfortunately. All right, we are getting a caller. Let's see. Excuse me. I think your name is Jay. Is that your name? And if so, oh no, Jerome. Where are you calling from?
Seattle. How you doing? Good evening.
Wait, where are you calling? Seattle?
Seattle.
Oh, Seattle. Oh, my bad. What's on your mind, man?
My question is how long does the brain stay active after someone is considered deceased?
Sure, yeah. So, people are considered deceased for different reasons, of course, but let's say somebody's had their head cut off, right? I think, the prospects for somebody in that situation are not particularly bright. And so it's kind of tough. It depends on what you're interested in. If you're interested in how long is someone conscious, right? How long could somebody, are they taking in information, and could they, if they still have their body about them, could they speak and, interact with you? It will be a while, but the moment that blood stops being delivered to the brain, particularly at that level, if the heart stops beating, for example, or of course the head is severed, the moment that blood stops being delivered, different parts of the brain begin to shut down. I don't know if you've ever experienced tunnel vision, like if you've been in the pool or, you've been swimming and you've been holding your breath for a long time, you start to your vision starts to tunnel down. You could imagine something like that happening, where a bunch of different components of your consciousness quickly begin to shut down. And so you're still technically alive. Well, you're still alive in the way that we're interested in, but you're not fully, it's not like you or I am right now, right? So it's going to be this rapid decline of consciousness. And it's kind of arbitrary where on that decline you determine one to be conscious and not conscious. But it'll be, so I all of this to say, there will be neurons that will still be alive for many minutes after one is dead. But those neurons don't necessarily sustain consciousness. And so, it's okay. So I can't give you...
Thank you for that.
I can't give you a specific number, but it'll be, a couple of minutes.
Gotcha. Thank you.
Yeah, no problem.
Appreciate
Thanks for calling
it,
in, man.
Go Hawks.
How dare you? Is it a defense mechanism? No, it's just a byproduct of... Well, that it is an interesting way to frame that. And thank you very much for the super hearts, Asha. It's lovely to see you, and thank you for reminding me. So it's interesting to frame it that way. One could make an argument that there is an evolutionary advantage to having the anatomy such that as there is a deficiency of blood delivery, that certain parts of the brain shut down and other parts are sustained. And this is evolutionary biology speculation, but my submission to you would be that it is not because that would be advantageous that the brain is devised in such a way. Rather, it is because the brain evolved in a certain way that the most central, most critical parts of the brain, that are necessary to be alive, for us to stay alive, are also the most ancient, right? You might call them the reptilian brain. They're in the brain stem. They tend to be towards the back and towards the bottom of the brain, by the way. Those tend to be evolutionarily more ancient, present in simpler animals, than the newer stuff, the stuff that is uniquely large in humans, like the forebrain, for example, the telencephalon, the neocortex. And so it is not, so again, it's not defensive necessarily. It's just a byproduct of how the brain evolved. And so, and it's a byproduct of how blood is delivered throughout all these structures. You are perfect to write Einstein's physical brain in a box, the real story. Your art in the background is cool. Oh, thanks a lot, man. I have a question. Well, I'll do my best. Okay, hey, and what's up? I'm Rodolfo, but I go by Rod. I'm from Sao Paulo, Brazil. Awesome. One of my best friends growing up was from Brazil. One of my earlier questions, your opinion of use of mushrooms or ayahuasca. Well, so, I mean, I would suggest to you that my opinion is kind of inconsequential. But here's how as somebody with really at heart, I'm a neuropharmacologist, perceives the family of drugs that we refer to as psychedelics, of which ayahuasca and psilocybin are counted among, classified. And that is that this is a unique family of drugs that enables us to perturb the nervous system in a unique way. And we call them psychedelics because they induce these really consistent forms of hallucinogenic experiences. So they tend to disrupt. They don't cause delirium. They don't cause somebody to just completely fabricate an entire vivid experience, right? That is just completely divorced from reality. There are drugs that will do that. Datura, for example, will do that. Diphenhydramine, by the way, over-the-counter drug, will do that at high doses. And I have a funny story about that, which I'm happy to get into if you guys are interested in. It involves scorpions. But this family of drugs, these psychedelic hallucinogens, they interact with unique parts of the brain. And that is the reason why you have these really interesting and unique set of hallucinogenic experiences. And so that's just cool, right? It's cool that, we have all these different molecules that can influence the brain and consciousness as a result in all these different ways. But they're useful beyond that. They're useful on two levels. One is that the way we learn about how consciousness works is we perturb the engine of consciousness, which is the brain. Back in the early days of neuroscience, some of the best neuroscience would emerge from brain injuries after wars or after sports-related, after jousting, where, oh my gosh, there's a spike of wood in a certain part of the brain, and it turns out that this person can no longer see. So maybe that part of the brain has to do with vision, right? So, you're not having neuroscientists stabbing people in the brain with a stake, but you're learning from a very perturbed circumstance. The same goes for addiction, where we can see, okay, if we, tickle these neurons with this specific drug, call it cocaine or nicotine or heroin, it turns out that these specific neurons consistently always get activated. So maybe not only are these neurons involved in addiction, but maybe they're also involved in the natural genesis of those emotional states independently of drug exposure. And that is how it works. We perturb the system and we see how the system operates in this perturbed state, and then we can learn about it in its natural state. Hallucinogens and psychedelics in particular, they perturb the system in a unique set of ways as a function of their neuropharmacology. And so we can learn a lot about consciousness and how the brain works by evaluating how they perturb the brain. Now, the second level that they're useful is that they might be quite clinically useful. And so, for example, there's a study that came out of Johns Hopkins. I just stumbled upon it earlier today, which is why it's top of mind, which showed that smokers, so just nicotine, cigarettes, not e-cigs, but cigarettes. I'm surprised the e-cig thing hasn't come up yet. But smokers who were, regular smokers, when they were given psilocybin in a clinical setting, so it's not like they were just given a bag of magic mushrooms and said, off you go, good luck quitting smoking. So these are people that were interested in quitting, I should say. When they were treated with psilocybin just 2 times, their abstinence rate, or they were trying to quit, and the rate at which they never smoked at after 6 months, so at a checkpoint of 6 months, was 80%. Okay, so that sounds like 80%. That's only 8 out of 10 people were successful in quitting for only 6 months, and that's fair enough. Nicotine is extraordinarily difficult to quit. Keep in mind, but standard treatments for nicotine cessation are far less effective. I mean, we're talking about in the 35% range at 6 months. So, that's just one example. Of course, psilocybin is now being evaluated for potential for potential use to treat psychiatric conditions like depression, post-traumatic stress disorder, and other psychedelics are being evaluated for a variety of other reasons. But so all of this to say, it's a very interesting, very potentially informative family of drugs. And it's a shame, I think, and we're sort of beginning to crawl out of the mire of this legal burden, that this family of drugs was most vigorously researched at a time when neuropharmacology was still rather rudimentary. And so as a result, you had people like, I was going to say Dennis Leary. Although maybe Dennis Leary too, but Tim Leary, who had a really, a respectable theory about the relationship between neuropharmacology and violent behavior, but had no idea what LSD was and what psilocybin was. You had these people that were just completely naive to what the nature of psychedelic hallucinations were. And so as a result, all this crazy stuff happened, and there's a government crackdown, and then for decades they were treated as poison. And they're just not, right? They're just more tools to potentially understand the brain at a better level, consciousness at a better level, but also potentially treat what can go wrong from the brain. All right. I'm a real numbskull, no help from me. I highly doubt that. I vape myself. That's another cool conversation we could talk about. Yeah, so I was specifically referring to the recent move by HHS, the Secretary of Health and Human Services, which is a large agency within the United States federal government, basically moved to just ban flavored e-cigs. And that was because there were these 3 deaths that were observed or that were noted that were associated with electronic cigarettes or just vaporizers, right? Now, the problem here is that, first of all, any death is tragic, of course. I don't think anybody would argue otherwise. But 3 deaths is not a large number compared to, for example, fentanyl or opioids, just pharmaceutical opioids in general, which are at, we're talking about dozens of thousands of people dying every year, greater numbers than ever in the history of the world. And so we're comparing 3 deaths to having approved sufentanil, an opioid that's even more potent than fentanyl, I think last year. Now, of course, that was the FDA, but, still the same federal government. And not only that, but the vaporizers that were being used that were associated with those 3, again, very tragic deaths, they were not actually vaporizing like, what you might call openly commercially available e-cig fluids. Like, they weren't using a Juul, or they weren't using a blue cigarette, or I don't know what all the brands are these days. I just know Juul because a lot of kids are using them, which is a problem. They were using sort of like gray market vaporizer fluid. And for me, and this is just my humble opinion as somebody that studies biology, studies neuroscience, for me, just banning them outright is not the answer. That, first of all, is going to make it way more dangerous because kids are going to kid. They're going to get access to flavored, vaporizer fluid. It is so widely available on the internet. So what's going to happen is that instead of having a large number of, or a set of companies that are responsible for producing a large portion of that e-cig fluid that we can point to if something goes wrong, now they're just going to be getting it from some random guy on the internet selling his own personal, mix of e-cig fluid. So in other words, standards are going to go down. It's going to get more dangerous. But then also, for me, this is an indication that, hey, maybe we should be regulating this. Maybe there should be part of the FDA or the USDA or whomever that is responsible for evaluating the presence of potential carcinogens or just toxic molecules in e-cig juice. For me, that would make way more sense. Legalize it. So just tax it, regulate it, treat it like alcohol. That, for me, is the answer. Not just like outright sledgehammering this industry that is, I'm sorry to say, big enough that people are going to continue getting illicit mango flavored e-cig juice. All right. I hope all's well with you. Hey, I'm doing pretty well at this. I'm a little sleep deprived because the only time now that I can read for the podcast is when I should be sleeping. But apart from that, I'm doing well. The baby's crawling all over the place. She's just there's just infinite energy to move. It is unbelievable. Do I have any relations with Martin Shkreli? No. I think I have spoken to him live once, but no. I've never interacted meaningfully with Martin Shkreli. All right, so you are so Darwin. Is that your name, and where are you calling from?
I'm coming from France.
Darwin from France. Oh, cool. What's on your mind?
What's that?
What's on your mind?
Oh, what's in my mind? My mind is when are robots gonna take over jobs?
Man, well, one could argue that they already have started to, right, through automation. I mean, a robot doesn't necessarily have to be intelligent. It can just do things that humans would otherwise do, but not have to go to the bathroom ever. So that's already happened. But given, one of the most, common jobs in the United States, I don't know if this is true for France, but I'd be surprised if it was very different, is trucking, right? Just driving trucks to deliver goods from one place to another. And we already know, I mean, the Teslas and a bunch of different cars now have completely automated driving, which is remarkably safe. And so pretty soon, I mean, one of this very large job category is going to be directly threatened by that form of robotics, that form of automation. But there was a study that came out, many years ago, came out of Cambridge that basically showed, these were economists, and they showed that there are just going to be waves of the, consumption of formerly human performed jobs by artificial intelligence. And so when is that going to happen? It is already happening, but it's just going to be this sort of steady progression. And of course, some jobs are perhaps more vulnerable to that than others. But they basically made the argument that if you think that because you're an artist or you're a musician or you're a scientist that you're protected against an artificially intelligent robot taking your job, think again, because that's just not the case. So I can't tell you a specific day, but I can tell you that it's already happening. What do you think, Darwin?
What I think is that I think if robots in like maybe 10 years time, they are going to take over jobs, definitely. I can assure you that. And there are going to be less jobs for human beings because, we can see flying cars, we can see drones. I mean, it is going to take over many jobs around the world, and it's going to be kind of a problem,
Yeah, I mean, I fundamentally agree with you. My only, source of apprehension to just completely believing that argument is that people have said that many times throughout modern human history, where once the automobile was invented, oh my God, all these jobs are going to be lost. And, oftentimes there's just the inception of new sources of jobs that can occur. I can't predict that is going to happen, but broadly speaking, I agree with you, man.
Yes.
We need to prepare for it. So thanks for calling. Good to talk to you. From France. Very cool. It's interesting that we are concerned over, much the same things. Elon Musk says to remain relevant, humans must merge with AI. Or I don't know if he specifically says artificial intelligence, but certainly computers. That is the premise of his company that he has termed Neuralink, which fairly recently had a public demonstration of some of their technology. I talked about Neuralink and whole brain computer interfaces at length on my podcast called Wired to be Weird on iTunes and Stitcher. And there, it's such a broad topic, and there's so much to talk about that you can get into science fiction, of course, but then you can also talk about some very prosaic aspects of having that kind of technology integrated into our brain. So, but yeah, check it out. It's called Wired to be Weird on iTunes and Stitcher and Google Play, and where you get podcasts. Hello, Barnes. Barnes MMA. Barnes Museum in Philly is a great museum. We have a huge problem with fentanyl where I live, not seeing use declining. Yeah, I mean, so I think last year was the first year in a while that total number of opioid overdose fatalities declined slightly. I think it went from like 73,000 to 70,000, just over 70,000 to like 68,000, which is massive. I mean, it's that like it's hard to put that into context. That is more than the total number. There was like a time not too long ago in the United States where like an alarming number of people were dying in automobile accidents. This is way higher than that peak number. This is way higher than the peak number of people who were dying during the crack epidemic, which you may or may not be old enough to remember. Which was the crack epidemic was responded to forcefully by the federal government and just local governments as well. And I would argue to you that there really hasn't been much of a response at all. Certain municipalities, like particularly in Massachusetts and I think New Hampshire, are experimenting with different things. I know in Philadelphia there is a very rigorous debate going on as to whether or not we should have safe injection sites. A part of Philadelphia is among the most devastated by the opioid addiction epidemic, let's say, then certainly also overdose epidemic. And it is really severe there. Like, particularly if you walk through that area, you can just see used syringes on the floor. That is totally unsurprising. Even in the area where I live, which is not even adjacent to that area, but it's not a walk away. It's like quite a while away. You'll see used syringes every now and then. It's wild. I mean, it's like, it's hard to put it into the magnitude of this issue into context, but the numbers are staggering. And the idea that like we really still haven't tried anything new other than make it harder for patients to get opioids, like that's our solution. That's not a solution. It's something that like is deeply frustrating to me. And the most frustrating aspect is that there's really not a diversity of ideas in this conversation. It's just like, yeah, this is pretty bad. Like, I don't know. It's tragic. All right. You detectable. Oh, wait. Deep fake. Look it up. It's an AI. All right. How can addicts have a chance at stopping usage? Well, I mean, that is, of course, the motivation behind the work that I have done in graduate school and my lab continues to do, or the lab of which I'm a part continues to do. Addiction is one of the trickiest conditions to treat. And, different drug addictions are more difficult to treat than others. But particularly opioid addiction is extremely difficult to treat. And, there's not a lot of, you basically have two avenues. One is motivating somebody as much as possible to just become abstinent and join a support group like Narcotics Anonymous or there are different sort of iterations of the same fundamental flavor, which is a social support network of people who are trying to stay clean. And or it's substitution therapies like methadone or Suboxone, which are different drugs, but they're accomplishing ultimately the same goal, which is to provide a small dose of the euphoria and the high that one used to derive from fentanyl or morphine, not really morphine, but heroin or oxycodone, but in a way that's far longer lasting and just enables folks to live a sort of sustainable lifestyle and staves off the worst of withdrawal. But, it's still an ongoing debate as to whether or not that is an optimal solution. My personal perspective is that it absolutely is. The stigma that still surrounds the use of methadone or Suboxone is, I think, literally dangerous. My answers are too long. Well, I'm sorry, Dope Solo. These are topics that inspire me. Oh, what happened? Oh no, you canceled. Sorry about that, dude. Okay, here we go. I believe your name is Jackson. Where are you calling from? Jackson, are you there? Jackson Fields?
Yeah.
Where are you calling from?
Florida.
From Florida. Okay, what's on your mind?
I fucking hate niggers. The problem with the opioid argument.
Sorry, man. I don't know if you were trying to make an interesting point there, but I kind of highly doubt it. All right, gross. Sorry about that, everybody. All this people protesting about climate change. I don't think anybody's protesting climate change here. Cool. the brain-computer interface may be able to hit opioid receptors and help suppress urge. So yes, I mean, absolutely. In fact, that has been attempted. Now, when you say like brain-computer interface, I think oftentimes, the image that crops up in their mind is something very complicated and like enables you to like quickly access the internet, and you're just as smart as any artificial intelligence, right? But we do already have brain-computer interface, and that doesn't exist, I should say. That doesn't exist yet. But we do have brain-computer interfaces that are used regularly, therapeutically. So, for example, to treat Parkinson's disease, we can implant electrodes that target a certain part of the brain that is deteriorating in Parkinson's disease, the substantia nigra. And those electrodes have to go very, very deep, but what they then are able to do is deliver a little bit of electrical current controlled by a computer that will enable complete cessation of Parkinsonian tremors, the classic tremors that I think are probably the most familiar component of Parkinson's. But that same treatment modality has been evaluated for the treatment of other non-neurodegenerative disorders, so conditions like depression or addiction. And in fact, deep brain stimulation has been evaluated for the treatment of addiction, targeting the nucleus accumbens, the ventral striatum. And so, yeah, 100%. I mean, but let's get crazy with this, right? Okay, so somebody's addicted to opioids, they get a brain-computer interface, to manage their cravings for opioids. But why stop there, right? I mean, think about this is a whole brain-computer interface. And so you could just, on a whim, decide to experience 5 seconds of a pure opioid-induced euphoria. But then just as quickly as it came on, it stops, right? You could just decide to spontaneously have an orgasm, right? Because that's all regulated by the central nervous system. And, the spinal cord is involved, don't get me wrong. But, you could, like, if we were able to profile the pharmacological distinctions between hydrocodone, oxycodone, morphine, diamorphine, or heroin, and fentanyl, you could just progress through them and experience the slight, subtle differences between what it's like to stimulate the brain in this way or that. Treating a condition like addiction when you have a true whole brain computer interface will likely be rather trivial. But the problem is, of course, getting there, and just the amount of information we're going to need to be able to process like that to enable successful treatment of anything. Well, really, to have a meaningful whole brain computer interface is massive. And we're just not remotely close to the point of being able to process that amount of information at once. Coffee, please. Well, so imagine this. Imagine, ever since I was in college, I wanted to invent this device where you could, put it in your mouth, and before you woke up, it would open and then release some caffeine that you could then absorb, sublingually. And so you could just very efficiently get your caffeine. This is, of course, when I was in college, and so I had organic chemistry at 8 in the morning. Which might not be early for some of you, but it is way too early for me. Unfortunately, I never developed that. But if you could imagine having a whole brain-computer interface, then, yeah, I mean, you could just program yourself to fall asleep at a certain point and then wake up at a certain point perfectly ready and, refreshed. Now, I'm talking about this as though it's a trivial matter to achieve once we have a whole brain-computer interface. It's not trivial. It will be many, many, many years in the future until we could realize something like that. But that said, there's no law of physics that's preventing that from happening, right? What about boyfriends? Plus, we need the endocannabinoid receptors synaptic strength regulation. I'm not quite sure what you're referring a bit. Sorry about that. Do you have any advice on how fentanyl addicts can kick the habit? Oh man, I mean, I am a PhD candidate for now. Only. I am not an addiction medicine specialist. So the best thing that somebody can do that has any addiction, from nicotine to even cannabis to, fentanyl. Fentanyl is a very serious drug to be addicted to. Arguably, among the more commonly used drugs, it is the most serious drug that one can be addicted to, because the difference between a high and an overdose is infinitesimal in dose. And so, it's not like trying to quit cigarettes, which is really, really tough, definitely really bad for you. But you're not potentially going to die tomorrow from an overdose, right? So the best thing that somebody can do in that situation, if they want to quit, which is very difficult if somebody doesn't want to quit, for them to quit, is to go talk to an addiction medicine specialist. They have resources, they have tools to enable somebody to get through the severity of withdrawal from a drug like fentanyl. And depending upon their life situation and so on, there are options available. It is not it's not, it's more precarious than, I can't think of any other drug that would be more precarious. All right. Choose your soulmate sober. That is like a component to it, right? Changing one's environmental, a repertoire of environmental cues that can trigger a craving for opioids. People can be those triggers. Zane is in here. I haven't seen her comment, but glad to see you. Hope all's well in jolly old London town. Okay, the question is, are we getting closer to finding this cause or cure for Parkinson's? Yeah, I mean, compared to many other neurodegenerative diseases, we know quite a lot about Parkinson's disease. It is arguably a more straightforward neurodegenerative disease than one like, let's say, Alzheimer's disease, because it is a specific population of neurons, mostly, that are affected by the progression of the disease. And we do have some pretty successful treatments for it. Of course, we don't have any cures for it. And so I don't know what the most compelling avenues of research for cures of Parkinson's might be. But, I know that there are like almost at least monthly discoveries regarding, how to target alpha-synuclein, for example, to prevent the neurodegeneration. My watch thinks I'm working out right now. Weird. Similarly to the way that we would target aggregates associated with like Alzheimer's disease or, other neurodegenerative disorders. All right, this could be a problem, or this could be good. Now, the problem is I don't know where my email window is. Okay, here we go. I'm almost there. It's not coming up. Weird. The call was not coming up, so I couldn't pick it up. Sorry about that, folks. All right. The question. Okay, right. Hello, McLaughlin. How does the brain produce cortisol? Sure. So how does it? So cortisol is a member of a family of hormones called glucocorticoids. Generally speaking, the glucocorticoids are elevated during times of what you might call environmental challenge or stress, just sort of colloquially as, stress. And what cortisol does is it sort of prepares us to greet this environmental challenge. And what that environmental challenge would be evolutionarily would be being threatened by a predator or by a potentially warring band of Homo sapiens, and glucocorticoids. And but of course, we very rarely are greeted by roving, attack felines, at least not generally. And usually we're not dealing with Homo sapiens that are threatening our survival on a day-to-day basis. Of course, some are, unfortunately, but we still have that same biological system that is responsive to environmental stimuli that we perceive as threatening. And so cortisol levels can be elevated, when you're about to give a talk, or when, you're starting a new job, or trying to pick up somebody that you're attracted to. I guess I don't know where else to go with glucocorticoids. The part of the brain that I study has receptors for glucocorticoids. Your favorite. I do look extra tired because I was up pretty late reading about fasting, which will be the next topic of the podcast. I can basically only read for extended periods of time when I should be probably sleeping at this point. But I'm pretty excited for it. I found some really good reviews on fasting, and what's great about finding a review on a topic is that it can frame the way you think about the topic in a deeper context than you would if you were just approaching the biology at baseline. I'm sure this doesn't sound particularly exciting for anybody, but like putting the biology of fasting, of intermittent fasting, or alternative day fasting, or the fasting that's associated with like certain spiritual traditions, putting that in an evolutionary biological context is really useful for me when I'm doing a literature review for a podcast. So that'll be the next topic, is fasting, and specifically fasting, the effect of fasting on cognition. So yeah, talking with your hands is a workout. That must be it. Like it still thinks I'm working out. It didn't used to do this. Thank you for this. Oh, it's my pleasure. Are you kidding me? Trupa, it's good to see you. I wonder if there are slow processes that, brain-computer interface cannot expedite, like diurnality and gonadotropin release. Yeah, as I was talking about like how you might be able to use a whole brain-computer interface to like optimize sleeping and waking, that was going on in the back of my mind. I was like, wait, why would we still need to sleep? But my suspicion is that even with the let's say the early iterations of an effective whole brain computer interface, my suspicion is that there will be molecular processes that are not electrophysiological, like what goes on during sleep, that would be that even a whole brain computer interface would be incapable of accommodating, at least early on. Now that said, I mean, why couldn't if we're talking about fancy technology, why couldn't you have one that could have a pharmacological effect on molecular pathways, like activate the lymphatic system to clear away all the detritus from neurotransmission? Why not? But yeah, broadly speaking, your point is well taken, which is like there are processes that occur, biological processes that are not rapid on the level of what we care about for consciousness, generally speaking, and it's molecular cascades, biochemistry, which is very slow usually comparatively. All right, I had my poster presentation, unintentional thesis defense, on Friday. Now I'm not a student anymore. Whoa, that's a big deal. Are you serious? Congratulations. I assume it went well, although I guess you could also not be a student if it went poorly, but my suspicion is that it went pretty well. How do you reduce cortisol? If your concern, and again, I'm just a PhD student, if you are concerned that you have dangerously elevated levels of stress, and that is the or just suboptimally elevated levels of stress, if that is what has inspired you to be interested in cortisol, then I would suggest to you it's probably not particularly useful to practically useful to hone in on a specific signaling molecule, and rather it would be best to talk to a therapist or talk to a psychiatrist or a mental health professional, because just targeting one molecule never really works in psychiatry. Like, it doesn't really work very effectively for the treatment of depression or certainly addiction. So that's that. If I were in your shoes, that would be my first step. Now, doing things like that have been shown by some groups to reduce levels of stress, which is, I think, the conversation we're actually having, like mindfulness meditation, might get you to where you're interested in getting, but again, that is that wouldn't be my first step. So yeah. Does cortisol increase inflammation? Actually, it decreases inflammation, which is perhaps a frustrating component of it, but that is part of the reason for why chronic stress can be associated with immunosuppression. So, and this is kind of, I don't know how inside of a joke this is among professors, but then also TAs in particular, is that right around midterms and right around finals, you'll tend to see students get sick more frequently. And in some cases, they'll have more cold sores, and that is because they're getting less sleep oftentimes. But also, it's just a stressful time, right? Where all of you're getting quantified. Your performance is being quantified, and it is unfair and horrible, but it is part of going through college. And part of the biology of that is the elevation of cortisol. So, for example, my baby right now has a little bit of a rash on her belly, unfortunately. It's going away, though, and we haven't had to use it, but one of the things that you can use is essentially a synthetic source of cortisol, hydrocortisone cream, that will reduce inflammation. So you might have heard of non-steroidal anti-inflammatory. This is a steroidal anti-inflammatory. So yeah, it doesn't elevate inflammation. At least that's not its first signaling effect. It can result in biology that can be associated with increased inflammation, but no, generally speaking, glucocorticoids reduce inflammatory signaling. Do you ever wonder how full of S you are? Stop talking, bro. Real science is not an on parody. So I do wonder how full of S I am on a very regular basis. Going through graduate school is a profoundly humbling experience, if only because oftentimes the students in your cohort are so much smarter than you, which was the case in my experience. And so yeah, I do wonder about that regularly. I'm not going to stop talking, though, because that's literally the only reason I'm here. And there are some other folks in here that at least we might presume might be interested in other things we might talk about. And then Real Science does not end up on Periscope. Well, or on Twitter, you might say. I would suggest that you take a look around. In institutions as august as the National Institutes of Health, Massachusetts Institute of Technology, a bunch of European institutions have just literally broadcasted talks from scientists to other scientists. I have in the past actually live streamed microscopy, like if I inject a virus and it does what I want it to do. We have an engineered virus that has a specific set of instructions. It has a certain set of skills, and it executes those skills wonderfully. I used to do that, but I just haven't done that work recently. But I'll probably be doing it again pretty soon. So I will show you real science, and it'll end up on your little device. Let's see. I have a bad skin condition. I'm sorry to hear that. Livoscope, it's so interesting. Well, thank you very much, Warrior Grandma. Nice of you to say. So take that, other guy. All right. Put tomatoes on a rash. It's funny. Everybody seems to have their baby rash response, some of which is just like, don't worry about it, it'll just go away. But like, I had different professors, let's say, at a poster session that I went to on Friday, say like, oh, you got to use apples, or you got to use, I think somebody did bring up tomatoes. Oh, somebody else brought up blueberries or grapes. One of them was like, oh, everybody's probably bringing this up because of quercetin, which is like a polyphenol molecule that's present in the skin of a lot of these fruit. And it's just funny that it seems like every family has their own little lineage of remedies for these conditions. But she's doing just fine. Like, it's really not that bad. It was bad for a little while, but it's not that bad. Good night from Pakistan. Oh, cool. Likewise. Well, good afternoon from Philadelphia. Okay. How does vertigo affect the brain? I know it's connected to the alignment of the crystals in the ears. Yeah, I super frustrating. I did a little bit of reading on vertigo not too long ago, but all the details are completely escaping me now. There was like a new treatment that came out for vertigo, or yeah, super frustrating. Sorry, it's escaping me. But what our friend here, I don't know if you want me to use your real name, I believe it starts with a V, is referring to are the very strange little sacks of salt water and basically little nuggets of like seashells that are present not in our ear, but like just adjacent to the inner anatomy of our ear. So the semicircular canal and the otolith organ. And you literally have these fluid-filled sacs, that, like salt water essentially, that are populated by little hair cells that are a lot like the hair cells that we use to hear different frequencies. But what happened, the reason that you know that you're spinning this way, for example, or that this direction is down, or that you're moving forward, is because you have these tiny little nuggets of calcium carbonate just jostle around and hit these hair cells. So I don't know if, yeah, super frustrating, but I should write these things out. But that is what our friend is referring to, our vestibular system. Just a huge part of our brainstem, by the way. I have severe vertigo. I get so dizzy that I pass out even while driving. Ooh, jeez, that is, I'm sorry to hear that. My God. Thanks a lot, Papa Smurf. That's very nice of you to say. All right. best book resources in psychology for medical students. Well, I'm not a medical student, so I couldn't tell you. And we of course had to take some psychology classes in college, but in graduate school we didn't have a psychology class. So yeah, I'm not sure. I couldn't point you in a great direction there. I could tell you about my favorite neuroscience textbook, but and it goes into psychology there, but it's not really a psychology textbook. Supposedly Einstein, Ben Franklin, and Thomas Jefferson had Asperger's. Huh. That's interesting. I'm not quite sure how that would have been. I could imagine somebody maybe speculating, that might be the case. And I wouldn't be surprised, certainly for, Einstein or somebody like him. But I'd be a little bit skeptical of sort of retrograde diagnoses of that kind. But it wouldn't shock me, certainly. Grad school is rife with students with imposter syndrome. I'd say it's a humbling experience. Yeah, no kidding. But yeah, it is definitely a humbling experience. Best type of drinks to keep you hydrated. Water is really excellent for that, but coconut water is really good for that. My wife has recently been getting into coconut water more and more. I used to be an avid coconut water drinker. But yeah, generally speaking, probably just water is pretty reliable. It's pretty unlikely, unless you're like an athlete running a marathon or like engaging in athletics, that you have an electrolyte problem. Like that is, it's just like salt. It's essentially a little bit of salt. Like when, a beverage would be like, enriched with electrolytes. They don't really do it as much anymore because I think everybody sort of caught on to what they were doing. But it's just like it has a little bit of salt in this water, and that, enables all of this amazing stuff that you couldn't do otherwise. And it's just like super unlikely that you have an electrolyte imbalance. Again, unless you're like in peak athletic performance. So yeah, nicotine addiction for non-smokers. Nicotine addiction, like in e-cigs, and I don't know how common it is for somebody to get addicted to the gum. But of course, there's like snus or dip, I guess some folks call. Yeah, I guess I'm not quite sure what you mean. So it is different. So for example, when somebody transitions, if they transition from smoking cigarettes to vaporizing nicotine, using an e-cig, they do undergo withdrawal, which is very interesting. And this was like one of the first things I started studying when I began my research for graduate school was nicotine addiction. In fact, all of my publications are at least about nicotine addiction, if not a little bit extra. But one of the things I was interested when I was doing this review was like, oh my God, I didn't know that nicotine wasn't like the only active ingredient in tobacco. It's not. There are a bunch of other, you might say, psychoactive components of tobacco that have some pharmacological effect. And, again, you have this withdrawal syndrome that folks experience when they try and quit smoking cigarettes by using e-cigs. So there's something there that is meaningful, some psychoactive component or some pharmacologically relevant component that is absent from just nicotine in vegetable glycerin. But that said, quitting nicotine... So nicotine is an interesting drug to talk about in the context of addiction, just because it's not particularly rewarding. Like, it's not rewarding like cocaine is or heroin. It's not even close. It does alleviate anxiety for folks who are anxious. But over the course of a day, if somebody continues smoking or vaporizing nicotine, as many usually do, like self-reported levels of anxiety are actually exacerbated. So it's not like a very sustainable approach to mitigating anxiety. But there is a pretty substantial difference in how difficult it is for folks to quit nicotine. And we know some of the genetics behind this, or at least some of the genetics that predicts this. So, for example, if you have a single nucleotide polymorphism or a SNP, in a gene that encodes, unsurprisingly perhaps, one of the components of a nicotinic acetylcholine receptor, so named because it binds nicotine as well as acetylcholine, the alpha 5 subunit, then we know that you are much more likely to smoke way more cigarettes in a day, and it's likely to be way harder for you to quit than somebody that does not have that polymorphism. Interestingly, though, it seems that those same folks who are predisposed to nicotine addiction are protected against cocaine addiction. It's an ongoing question that has yet to be answered. Why? Why is that the case? Why would that be the case? But yeah, it's an interesting topic, and like for a very long time, the field of addiction biology was like hyper focused on cocaine, and other drugs were studied, but even still, I would argue that compared to like the number of labs that study cocaine is like not proportionate to like how many people actually still do cocaine. It's like not whatever. That'll change very soon because there's a lot of funding that is going to be mobilized to study opioids. But it is this like odd kind of just feature of addiction biology. Okay. I see crackheads smoking ports every day. I'm not quite sure what you mean by that. Crackheads smoking ports. You're talking about like robots smoking ports? I'm not quite sure what you mean. Especially like the recent e-cig related fatalities could be from botched products. Yeah. Well, I mean, so that certainly the articles that I saw suggested that the e-cig juice that these folks. So this is referring to, I believe there's 3 fatalities of folks who were vaporizing, using e-cigs. And I believe they had THC in the e-cig juice, which is of course not legal federally. But it also indicates that they were getting their e-cig juice or manipulating their e-cig juice at a minimum, but probably getting their e-cig juice from, a source that is not as widely consumed as, let's say, Juul or, Blue cigarette or Blue e-cig. Again, I don't know all the companies. I just know Enjoy is the one I always see in gas stations. And so, yeah, I think you're absolutely right. And like, I went into greater detail earlier, but there is a move now by Health and Human Services, which is again this giant department of the federal government. The NIH, for example, is part of Health and Human Services, but is moving to completely outlaw flavored e-cig juice or flavored e-cigs. Period. So it doesn't mean e-cigs are going to be illegal, but it does mean that you're not going to see like mango and mint and apple and like all the various flavors. And whether or not that's a justifiable or an optimal approach to the issue of whatever people consuming nicotine, that's a different conversation. But in response to these tragedies, it doesn't really make sense to me. Like to me, the first thing that came to my mind when I saw this was somebody ought to be regulating this e-cig fluid, right? Somebody ought to be spot testing, or is there anything that's known to be carcinogenic in this e-cig juice? More importantly, in my mind, is somebody should be testing the various flavorant molecules that are used. Different flavorant molecules can be used to achieve the same general flavor, category of flavor. But we know some of them, when they approach a certain temperature, which may or may not be lower than that of nicotine vaporizing, they undergo combustion. They produce carcinogenic molecules. So like we can, it is possible to make e-cig juice that does not have those, that are not composed of those threatening molecules. But there's just no entity, not governmental or otherwise, that is evaluating these products to any standard that would approach something acceptable. So, to me, this is a giant industry now, right? It's a multi-billion-dollar industry, and it's just exploding, showing no signs of reducing. Who knows what this move will have, what effect this move will have, but tax it. Tax this industry and use some of those funds to regulate the industry. Like, it's just, I don't understand, like, why that's not the approach. You could also, by the way, fund nicotine recovery, research and nicotine recovery centers. You could subsidize, nicotine recovery pharmacological aids. You could do a lot. So, but just like saying, well, this happened. And again, it's tragic. Anytime a young person, particularly, but anybody, dies from a product that they had no idea, might result in this consequence, it's tragic. But it is 3 compared to large numbers of people who are dying from other drug-related, let's call them products. So, yeah, it didn't really make sense to me why that would be the approach. Is brainwashing a medical condition? I'm not familiar with any like formal identification of brainwashing as like in like the DSM-5, which is sort of like, it is literally the manual for the diagnostics of mental conditions or psychiatric related conditions. So no, I'm not familiar with that being a formal medical condition. All right. Oh, that's right. I should check what time it is. Let's see where we're at. I should probably get going, you guys. So thank you so much for hanging out. My name's Ian McLaughlin, just in case it's not clear. I have a podcast, and it's called Wired to be Weird, and it's on iTunes and Stitcher. And I am working on the next episode. It's going to be about the effects of fasting, intermittent fasting, alternating day fasting on cognition and brain health and longevity. So that's Wired to be Weird on iTunes and Stitcher. If you have funds to spare, I have a Patreon. It's patreon.com/anthropoid. And I would appreciate any support, but I understand not everybody is able to, so I will never put anything like that behind a paywall. So have a great beginning of your week, and I hope to, at a minimum, see you in the same place, same time here to talk about the brain. See you guys. All right, awkward time. There's the baby. Gotta stop streaming. Bye, everybody.